Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life.
If the end of 2025 feels less like a quiet transition and more like the planet is letting out this massive pressurized groan, you are definitely not alone.
Yeah, that's a good way to put it.
I mean, we are just staring at a period of intense global stress right now.
Yeah.
There's this dramatic convergence of, well, everything. Volcanoes erupting for the first time in history.
Right, seismic swarms.
Exactly. Continuous swarms across the Pacific, catastrophic floods, massive wildfires, and all this is happening just weeks after we were hit by the strongest solar storm in 2 decades.
It absolutely creates this feeling of global synchronization, almost like a planetary fever pitch. And, in terms of human crises on the ground, that chaos is very real.
So that's our mission today.
It is. Our mission is to take a deep dive into all this geologic turmoil to figure out what's really driving it. Is this truly an interconnected event where the deep Earth, the sun, and our climate are all, working together?
Or is it just a really, really bad coincidence?
Exactly. Or are we just seeing a collection of fiercely independent crises that just happen to be overlapping right now in late 2025? We need to look at everything to find out what really matters.
Okay, so let's unpack this global stack of sources. We have to start with the most jaw-dropping geological surprise of the year.
Haley-Gobi.
The resurrection of the Haley-Gobi volcano in northern Ethiopia in the Afar region.
Resurrection is exactly the right word. On Sunday, November 23rd, this massive structure just went active.
And here's the absolute key nugget that makes this so profound. For us, for scientists, for everyone watching, this was the first eruption in recorded human history.
Right, which is it's hard to even process. Geologists estimate this volcano had been dormant for a staggering 10,000 to 12,000 years.
12,000 years. I mean, think about that. That predates settled agriculture. It predates civilization as we know it.
It really does. It's the geologic equivalent of a 12,000-year-old sleeper agent suddenly going active. For a volcano to sleep that long and then wake up with such intensity, it just completely shifts the background noise of what we consider normal global activity. Most volcanoes we track operate on cycles of decades, maybe centuries.
Not millennia.
Not millennia.
And the scale of the eruption itself was immense, right? It wasn't just a little burp.
Oh, far from it, no. Satellite imagery showed this massive column of ash. That plume shot up 8.7 miles. That's 14 kilometers, straight into the sky.
It's what, higher than a commercial flight?
Much higher. A typical flight is around 6 miles, so you start to grasp the sheer force it took to push all that material up through the atmosphere.
The reach of the event was just terrifying. That pale ash plume. It drifted far across the Red Sea, didn't it?
It did. It caused multi-day flight cancellations as it moved over Pakistan and northern India.
And kept going east.
And kept going toward China. So an eruption in a remote part of Africa suddenly becomes a problem for global aviation, for air quality across continents.
So that's why those high plumes are so critical to track.
Absolutely. The good news, though, is that the activity at Haley-Gobi, it ceased pretty quickly. It was reportedly done by November 28th. But this brings us back to the context. This is Ethiopia's Afar region.
A major rift zone.
One of the most tectonically stressed regions on the planet. The Arabian and African plates are literally pulling apart there.
So fundamentally a rift volcano, but its behavior waking up after 12,000 years, that's what's so strange.
Precisely. And we have to contrast it with its neighbor. The Afar region has seen other activity this year. erupts volcano, for example.
The one with the lava lake.
Right. Famous for its pretty stable, continuous lava lake. Well, it reported a dense black cloud rising way back in mid-July. That contrast is important. erupts is constantly releasing heat and gas. That's normal for a rift volcano.
That Haley-Gobi was just sitting on it.
For 12 millennia. It shows that even in these high-stress zones, massive amounts of material can just quietly board up until the geological conditions are just right for a monumental release.
So whether dormant for 12,000 years or continuously active, fundamentally these events are just the Earth doing its job.
Right.
Releasing heat along those plate boundaries.
Exactly. Volcanologists often call them Earth's thermodynamic safety valves. But, when a valve that hasn't blown in 12,000 years suddenly goes, it's a powerful reminder that these deep tectonic forces are just relentless. And they operate on timescales that completely dwarf our own existence.
So if Haley-Gobi was the surprise headline, the rest of the planet's hotspots are just putting in continuous overtime.
That's a good way to describe it.
When you look at the sheer volume of seismic data, especially from the Pacific Ring of Fire, it's just humming with activity. I mean, let's take Indonesia as a perfect example.
Okay.
In the last 30 days alone, they recorded over 1,400 earthquakes nationwide.
That volume it's staggering. It gives you a sense that what we perceive as this period of intense stress is partly just the baseline activity of these hyperactive zones.
Which we can now monitor with incredible precision.
With microscopic precision, yeah. Indonesia sits on a collision zone of multiple plates, so frequent quakes are normal. But 1,400 in a month is definitely elevated, even for them.
And what's fascinating is the contrast you see even within one country. You've got Bali, where Mount Agung is at the lowest alert level I, normal.
Right.
Even though they've had deep volcanic earthquakes, they're actually telling tourists not to panic about the white smoke they see.
Saying it's just steam from the rain.
Exactly. But then, less than 1,000 miles away, on Java, Mount Semeru is on the highest alert level possible.
Right, since November 18th. This localization is so key to understanding these hazards.
So why is it so localized? Why isn't the tectonic stress pushing Agung to erupt if it's pushing Semeru to its maximum alert?
It all comes down to the plumbing.
The plumbing.
The plumbing, think of the tectonic forces as the general pressure cooker for the whole region, but each volcano has its own independent plumbing system, its own magma reservoir, its own unique structure.
So the pressure might be high everywhere, but only Semeru's pipes were ready to burst.
That's the perfect analogy. Semeru's chamber was ready to breach now, while Agung's is still sealed. It really shows that these global trends are often just a series of highly isolated local crises.
That distinction really changes how you think about monitoring. Okay, let's move over to the U.S. hotspots. Let's start with Kilauea in Hawaii.
Kilauea has been in an ongoing episodic eruption since late December of 2024, and it's dramatic. We've seen lava fountaining, sometimes reaching over 1,000 feet. That's 300 meters high.
Just incredible.
It is. A constant, visually stunning display of power, but it's contained within the Halei-Gobi crater.
Right, so the lava staying in the park, what's the real danger we should be worried about there?
It's the air quality. The crucial hazard isn't the lava flow for most people, it's the volcanic gas, specifically extremely high levels of sulfur dioxide, or SO2.
And that creates VOG, the volcanic smog.
Exactly. It reacts in the atmosphere and creates this fog.
You mentioned the emission rate is just astronomical, something like 50,000 tons per day.
During these episodes, yes. 50,000 tons of SO2 a day.
Can you put that number into perspective for us?
It's an enormous volume. It's significantly higher than the daily industrial SO2 emissions of many major global cities combined.
Wow.
It creates this vast, invisible, airborne health hazard downwind. It impacts respiratory health. It affects agriculture. The hazard is widespread and relentless.
Okay, let's shift to the giant simmering pot under the U.S. Yellowstone. Is the supervolcano getting in on this?
Well, Yellowstone did show elevated seismic activity in November, which of course always draws attention. We located 251 earthquakes in the park region last month.
251, that sounds like a lot.
It is elevated, but it's not unprecedented for Yellowstone. What was notable were the 3 distinct earthquake swarms.
And swarms are just a bunch of small quakes happening close together.
Exactly. And they often relate to underground fluid or gas movement, which is, totally normal in a massive thermal system like Yellowstone.
I also saw reports about minor hydrothermal explosions at Biscuit Basin. That sounds terrifying.
It does sound terrifying. But it's essential to understand the language here. A hydrothermal explosion is not a magmatic eruption.
Okay.
These are basically steam explosions. Superheated water flashes to steam and blows out a small crater of mud and rock. They're shallow, driven by geothermal heat, not deep magma.
So dangerous if you're standing right next to it.
But they are absolutely not an indicator that the supervolcano is about to erupt. For the vast majority of North American volcanoes, activity is either at background levels or consists of these brief expected events.
So we've mapped this whole complex moment. A 12,000-year sleeper volcano wakes up.
The Pacific Ring of Fire is constantly shaking.
North America's thermal areas. Strongest solar storm in 2 decades, plus catastrophic fires and floods. It feels like this period of intense, overlapping stress.
It really does.
Which brings us back to that central intriguing question. Is there some mechanism connecting all this? The deep earth, the sun, the climate? Is it all one synchronized burst?
That is the ultimate question. And when we look at the scientific consensus, we need to be very, very clear. The dominant view is that scientists caution heavily against seeing this as some mystical planetary upheaval.
So, no connection.
Experts assert there is no proven correlation between volcanoes, earthquakes, and solar storms. They're governed by fiercely independent processes. Tectonic forces, the slow, deep movement of plates are the drivers.
But let's pause on the solar link,
Oh.
because if we had the strongest solar storm in 20 years, people are going to make that connection. It just seems too coincidental.
And that's where critical thinking is so vital. Scientists have looked at this. They've explored the theoretical mechanisms for what they call the solar hypothesis.
Okay, what's the idea there?
The idea is that extremely energetic particles from a solar flare could potentially trigger subtle, tiny changes in atmospheric circulation. And this change, in theory, might influence the highly pressurized cap of a shallow magma chamber, maybe provide the final minuscule push.
So it's a tiny atmospheric nudge, not a cause.
Exactly, a nudge. But when researchers analyze historical data, which covers centuries of solar activity and eruptions, they find no clear statistical connection.
So big eruptions happen during quiet sun periods, too.
Exactly. Major eruptions have occurred during both solar maximums and solar minimums. It's an interesting idea, but the evidence just isn't there. The sun is likely off the hook.
Okay, so the sun is probably a coincidence. But what about the other major planetary crisis? Rapid climate change. That affects massive systems on the surface, water, ice, pressure. Does that connect to the geology?
Now, this is where the science gets really nuanced, and it's probably the most important connection to understand for the future. While climate change doesn't cause tectonic events.
It won't create a new volcano.
Right. But the climate hypothesis suggests it can definitely modulate geohazards, and it does that by altering surface loads.
Surface loads, can you explain that simply?
Sure. Think of the Earth's crust as being elastic, like a huge mattress. Faults in magma chambers are sensitive to the weight pushing down on them. A change in surface load means adding or removing enormous amounts of weight quickly.
Like melting glaciers.
That's the perfect example. Rapid glacial melting removes immense pressure, or the filling of a massive reservoir adds pressure. Even extreme rainfall, like the floods in India and Pakistan, alters the weight and saturation of the crust.
So melting ice or heavy water subtly changes the pressure below, which could affect the timing of an event.
Precisely. These changes alter the stress on faults and magma systems by tiny but potentially significant amounts. The unloading of weight from melting glaciers has been linked to increased volcanic activity over decades in places like Iceland.
So climate change influences the timing.
It influences the timing, especially in these rapidly changing landscapes. It's a subtle mechanism, but it directly connects the human-influenced atmosphere to the deep Earth.
What's fascinating, then, is this dual reality you've laid out. You have the planet's deep interior operating on these vast, inhuman timescales. That's the real engine here.
Yes. And at the same time, you have the planet's surface systems, the atmosphere, the ice sheets undergoing rapid human-influenced change. And that surface change might not cause an eruption, but it can subtly influence the timing and likelihood of some events. It adds another layer of complexity to risk assessment.
And that brings us back to the technology we use to see all this. Whether it's tracking ash from a 12,000-year-old volcano with satellites or monitoring tiny seismic swarms under Yellowstone, observation is just key to preparedness.
It is.
And these technologies, they don't just record disasters, they change how we perceive them. They make a flood in Asia, a fire in California, and eruption in Africa feel like one single precarious global event.
That is the inescapable conclusion, isn't it? The world isn't necessarily more synchronized, but our ability to monitor and connect these independent events in real time is. It shrinks our perception of distance and independence. We are living in a moment of unprecedented global awareness.
So consider this final thought as you synthesize this deep dive. If changes in surface load from melting ice can subtly influence volcanic activity over decades, what other seemingly disconnected planetary systems might be nudging Earth's geology? Maybe deep changes in ocean currents or shifts in the global water table. And what happens when those subtle influences move beyond the theoretical and become reliably measurable in our lifetime? That is the next great frontier of geohazard research and connects climate science directly to the crust beneath our feet.
Don't forget to like and subscribe for the next episode on While We Were Distracted.